when it combines with another atom of different element. That time we'll call it is a molecule. Atoms of different elements combine with each other in order to complete their octet, which is whenever it is getting less, that will be plus, whenever it is getting more, that it will be minus. This is how the molecule and Lewis representation will be takes place. The number of electrons donated or accepted by an atom of the element is called electrovalent compounds. Hello everyone, this is Harshita Bhavasar from Vidhyaashram School of Excellence. Today we are starting up a new chapter, that is chemical bonding and molecular structure. Now we'll see the exam corner. For this chapter we need 20 hours to complete and the total marks allotted for this chapter is 7. Okay. So it is also a little bit important chapter to understand the structure of molecules and how the bonding between the molecules will happen. We will see one by one in a detail. Today's session we will discuss the introduction part, causal Lewis approach, types of chemical bonds. In that ionic and covalent bond will be discussed. Okay. First we will see the introduction part. Atoms of elements except those of noble gases do not have an independent existence. Atoms combine together and exist is a stable molecule. A group of atoms existing together as a single species and having characteristic properties is called molecule. The attractive force which holds various constituents together in a molecule is called chemical bond. To know the cause of combination of the atoms to form molecules, different theories have been put forward is indicated below. What they are telling means, atoms of all elements do not have any independent existence. Means in an element, all the atoms will be completely having the same feature or same nature with respect to physical or chemical. When it will be getting different, when it combines with another atom of different element, that time we will call it is a molecule. So how one molecule with another molecule will get bonded or will get combined? Through a bond, we will call it as chemical bond. Now in this chapter we will discuss about how the chemical bond has been arised, on what concept that chemical bonds will form, and what are the theories we will put forward to bring this chemical bond or to understand completely about the bonding nature and the structure of molecules. We will see here causal Lewis approach, valence shell electron pair repulsion theory, that is nothing but VSEPR, valence bond theory, that is VBT, molecular orbital theory MOT. We will see now causal Lewis approach. The stability or inertness of noble gases is attributed to their completely filled outermost shell or valence shell, which has general electronic configuration of NS2 and NP6, that is an octet configuration, and NS2 in case of helium, where N represents the number of outermost shell. Elements with electrons less than 8 in their outermost shell are reactive and combine in number of ways to attain stable octet configuration. See, this is one kind of approach, that is causal Lewis approach. The stability or inertness, in what kind of elements it will be there? In the noble gases, because its electronic configuration is NS2NP6. Means its outermost shell, that is called valence shell, the electrons will be completely filled. That will call it as octet configuration. It will be completely filled. Behind the electronic configuration of octet configuration, that is NP2, NP6, the electrons which have not filled till NS2, NP6, those elements will not be in a stable character. It will react with some other molecules. So the inertness will be less with respect to elements comparative to noble gases. So the elements with electrons less than 8, that is what I told, in their outermost shell are reactive and combine in number of ways to attain. Whatever the elements having less than 8, it will tend to combine with another electrons to form a complete octet configuration, because that octet configuration is most stable configuration. See here, Kossel and Lewis put forth their observation as octet rule, which is stated as follows. Atoms of different elements combine with each other in order to complete their octet. Okay, if one atom of an element, if it is not getting the octet configuration, but it tend to form a new compound or a molecule, what it will do? It will combine with another atom of different element. How it can do? The transfer of electrons will takes place. That's why that octet configuration will reach its stability. This is valency and valence electrons. Electrons present in the outermost shell of an atom are valence electrons, and they are responsible for the property of atoms. Valence is number of electrons lost or gained or shared by an atom while combining with other atoms to reach a stable octet configuration of noble gas. Atoms combine with each other to attain maximum stability and minimum energy. This is maximum stability and minimum energy. See, these are the electrons present in the energy levels, and the outermost energy, this is the outermost energy, the electron is present, that will be the valence electron. Then what do you mean by valency? The valency is the number in which the electrons will be gained or lost or shared between the atoms to reach the octet configuration. Okay. Why they will combine with one another? Because to gain stability with minimum energy. That is the reason why the electrons will tend to move with another electrons. According to the modern concept, valency is termed as the number of chemical bonds formed by an atom in a molecule. Now, after so many years, they told, like in the modern concept, how many bonds are present in the molecule, that many bonds will be considered as valency. Next, we will see the Lewis symbols. The valence electrons present in the outermost shell of an atom of an element are indicated as dots around the symbol of element. Lewis symbols are useful in determining the group valency of elements. Group valency is given by the number of valence electrons or 8 minus number of valence electrons. This is important. Group valency is given by the number of valence electrons or 8 minus number of valence electrons. The Lewis symbols of the elements of the second period and their valencies are indicated below. See here what they are telling. In the Lewis symbols, this is symbol of element. This is dot. Why? What is the dot? Means it is a valency of this element which will be indicated by one dot. Okay. Lithium is having one valency, beryllium 2, boron 3, carbon 4. Okay. It will be equal to number of valence electrons. See here, nitrogen, oxygen, fluorine, neon, 8 minus number of valence electrons. Okay. 1, 2, 3, 4, 5. 8 minus 5 means 3. 8 minus 1, 2, 3, 4, 5, 6. 8 minus 6 means 2. 8 minus 7 means 1. 8 minus 8 means 0. That is what this line will indicate. Valency is the number given by the number of valence electrons here, or 8 minus number of valence electrons will be called as the valency. That is what the Lewis symbols will show. Okay. This is the second period elements present in the periodic table. According to Kossel-Lewis approach, atoms of different elements combine with each other in different based on their nature and form different types of chemical bonds. Based on its nature, based on its different types, the different types of chemical bonds will form, that is ionic bond or electrovalent bond, covalent bond, coordinate bond and hydrogen bond. These are the 4 kinds of bond will be seen in the molecules. First we will see ionic bond in a Kossels concept. The electrostatic force of attraction which holds two oppositely charged ions formed by the complete transfer of one or more electrons from an electropositive atom to an electronegative atom. To an electronegative atom is known as ionic bond. The number of electrons donated or accepted by an atom of the element is called electrovalent compounds. Thus formed are called ionic compounds or electrovalent compounds. Example, sodium chloride, potassium chloride, magnesium chloride and potassium bromide and so many other compounds also there. See, to understand the electrostatic force of attraction which holds two oppositely charged. This is electrostatic force of attraction will be there between two charges. This is plus and minus, means it is formed cation and anion. How it will form cation and anion? See here, this is sodium, it is having one valency, this is chlorine. The outermost valence electrons are 7. See here electronic configuration 2, 8, 1, that is its atomic number is 11, this is 17. They have written the electronic configuration. The valence electron is 1, here 7. To reach the octet configuration, it has to get donated by sodium to chlorine because it is electropositive element to electronegative element. In the periodic table, the S block elements are more electropositive and the P block elements are more electronegative. We know that. That's why it is moving from electropositive to electronegative element. So, after reaching that, this is sodium will form sodium cation because it has lost one electron. It has been gained one electron by chlorine. It will form cation. It will form anion. Okay. That is how it is also filled with octet configuration. This is also filled with octet configuration. Between these two, one bond will form. That bond will be called as ionic bond. Due to the number of electrons donated or accepted by an atom, this compound will call it as electrovalent compounds and the bond will call it as electrovalent bond. Ionic compound will be called as electrovalent compounds also. Okay, these are the example. Next, lattice enthalpy. Lattice enthalpy is the energy released when 1 mole of solid electrovalent compound is formed from requisite number of corresponding ions in the gaseous state. It is the energy change for the reaction. These are the two compounds which gives to the solid. The lattice enthalpy will be released. See here, this is cation and this is anion. That Mx overall, both are gaseous atoms will form a solid state. Lattice enthalpy is also defined as the energy required to break the crystal lattice of 1 mole of an ionic crystal into gaseous ions separated by infinite distance. Lattice enthalpy is also defined as when the crystal lattice is there, that time to break that crystal lattice some energy is required. That energy will be called as lattice enthalpy. Lattice enthalpy is a measure of stability and ease of formation of an ionic compound. Due to the lattice enthalpy or lattice energy only, the formation of ionic compound will be easier. That is how the lattice enthalpy will be seen. Greater the lattice energy, more the stability of the ionic compound. When the lattice energy is more, that time stability of the ionic compound will be more. Next, properties of ionic compounds. Ionic compounds are crystalline solids. They have high melting and boiling point. Ionic compounds are good conductors of electricity in solution or molten state. Oppositely charged ions are held together strongly in their crystal lattice. Polar solvents reduce the force of attraction between the oppositely charged ions due to their high dielectric constants and high enthalpy of hydration. In solutions or molten state, ions are relatively free and are attracted by the oppositely charged electron. This results in the conducting property. Usually, ionic compounds are crystalline solids. Yes, we know that. It is very hard and they are having so much high melting point and high boiling point. They can conduct electricity in their solution and molten state. These are the major properties of ionic compounds. And the oppositely charges only, due to oppositely charged only, they will held together very tightly in the lattice. And polar solvents, if you use the polar solvents, it will reduce the force of attraction between the oppositely charges because the hydration energy is more in that. And in the solution or molten state, ions are relatively free, that's why that conducting property will be more. Okay, these are the properties of ionic compounds. Next, factors favoring the formation of an ionic or electrovalent bond. See, for the formation of electrovalent or ionic bonds, so many factors are favoring. What are those factors and how they are favoring? We will see now. Donor atom must be highly electropositive, that is, must have low ionization enthalpy so that the cation is formed easily. Donor atom means, see, in the NaCl, that sodium chloride, sodium is a electropositive element. It should be more electropositive because it should donate easily, and moreover it should have the low ionization enthalpy. Ionization enthalpy means to break some molecule, that to get ionized, that enthalpy is used. If the molecule is having low ionization enthalpy, it can break easily. So it can lose its electron easily, by that it can form cation very much fastly. So that's why the donor atom must be highly electropositive. Acceptor atom must have large negative electron gain enthalpy, that the anion is formed easily. Okay, that acceptor atom should have high negative charge to accept the electron whichever getting from the electropositive. Okay, that will call it as electron gain enthalpy, and anion will form very fastly and easily. Difference in the electronegativity between the two atoms must be large. See, if the two atoms or molecules whatever present in a electropositive and electronegative element, the electronegativity of two elements should be, difference of electronegativity should be large. If not, the highly positive electron will not form and highly electronegativity also will not form in between them. Okay. Lattice enthalpy of the compound formed should be large. Larger cation, smaller anion favors ionic bond formation. That is Fejan's rule. Larger the cation, smaller the anion. Larger the cation, why? It can donate easily the electrons. Smaller the anion means it can accept easily the electrons. So this both concept will favors the rule called Fejan's rule, that is valence bond theory. Okay. Next we will see the covalent bond, that is Lewis-Langmuir concept. The bond formed by mutual sharing of one or more electron pairs between the participating atoms is called covalent bond. The compounds thus formed are called covalent compounds. A covalent bond is represented by writing a thick line between the two atoms. Example, sharing of one electron pair leads to the formation of single bond. See here, this is hydrogen, its valency is 1. It is getting with another atom of hydrogen, that is hydrogen, its valency is also 1. It will form one pair of electrons. So, by this, it will form a thick line. This is called covalent bond. Means this bond will belongs to this hydrogen also, this hydrogen also. Okay, one bond will be equivalent of 2 electrons, that is one pair of electron. See here, same thing, fluorine having 7 electrons, this is also 7 electrons, which is one having, that will be bond up, lone pair of electrons. This is called lone pair of electrons, this is called bond pair of electrons, because this bond pair of electrons is involved in making of bond, which is not involved in making of bond will be called as lone pair. Okay. And this is hydrogen chloride molecule. This we have seen in a homoatomic, means same type of molecules. See, this is heteroatomic because different kinds of atoms are present. This is hydrogen, this is chlorine. Now, one from hydrogen, one from chlorine will form this HCl bond. Okay, sharing of 2 electron pair leads to the formation of double bonds. If it is 2 pairs are there, double bond, 3 pairs are there, triple bond. Only one pair is there, then it is single bond. See here, oxygen, 2 electron pairs are there, that's why double bond. In nitrogen, 3 electron pairs are there, that's why triple bond. The number of electron pairs shared between 2 atoms is called covalency. Here, if they ask in nitrogen, N2 molecule, how many covalency is there? What is the covalency of N2 molecule means 3, because number of bonds between the molecule is 3. Here, the covalency of oxygen is 2. That is how the covalency will be indicated. Next, the properties of covalent compounds. Covalent compounds exist as liquids, solids and gases. It is not like ionic. Ionic will be only in solid state, but in covalent, it will be all the 3 states. They are non-conductors of electricity. They are insoluble in water but are soluble in non-polar solvents. Okay, they cannot conduct electricity and insoluble in water, soluble in non-polar solvents. Reactions of covalent compounds are slow. These are the properties of covalent compounds. Next one, factors favoring covalent bond. Combining atoms should possess high ionization energy. What are the elements are getting to combine? That atom should have high ionization energy. Combining atom should have comparable electron gain enthalpy. It should, both the atoms which are getting to combine, it should have high ionization energy to leave the electrons. It should have the electron gain enthalpy also, because it should accept the electrons also. They should have comparable electronegativities also. Atom should possess 4, 5, 6 or 7 electrons in their valence shell. Okay, it should have the 4 to 7 electrons in the valence shell. High nuclear charge and small internuclear distance favor the formation of covalent bond. High nuclear charge and small internuclear distance. If 2 atoms having the internuclear distance very small, it can bond very easily a covalent bond. In all the examples given above, each one of the combining atom acquires octet configuration by commonly sharing one or more pairs of electrons. Okay, whatever we have seen, that electrons or molecules, one of the molecule will get completely octet configuration by sharing of electrons. Okay. Next, Lewis structures for simple molecules and ions. This is how the Lewis dot structures will be written. First, count the total number of valence electrons of the atoms present. If the species is an anion, add number of valence electrons. How many the number of unit negative charges are there? If the species is cation, subtract the number of valence electrons from the number of units of positive charge. This gives the total number of electrons to be distributed. If H plus means that electron should be added, Cl minus means one electron should be gained. Okay. Select the least electronegative atom as the central atom. Write the skeletal structure of it. Place one shared pair of electron between every 2 atoms to represent a single bond. Remaining pairs of electrons are used either in a multiple bond formation or as a lone pair of electrons. While distributing the electron pairs, it is ensured that each atom completes its octet. Means they are telling like this is one dot. Okay. This is also its electronic configuration or valence electrons. This will bond or it will be in a lone pair of electrons. Okay, this will form H plus, this is H minus, Cl minus. The 2 atoms should have the different electronegativities. That is how the bond formation will takes place, by losing or gaining of electrons. See, this is H2 molecule. How the bond formation takes place? This is O2 molecule, double bond. O3, this is one side double bond, one side single bond. Here cation is formed. This is NF3, see NF3, CO3 2 minus, how they have written? C, O and 3 2 minus. For 2 minus what they have done? 1, 2, 3, 4, right? This is the central atom. That's why 2 minus 2 electrons have been added for the central metal atom. By that their bond has been fixed. N plus, right? HNO3, that is N plus 1, 2, 3, 4. 1 is not there, one more electron, that's why it is plus. Which is whenever it is getting less, that will be plus. Whenever it is getting more, that it will be minus. This is how the molecule and Lewis representation will be takes place. Next, bond parameters. Covalent bonds are characterized by the following parameters, that is bond length, bond angle, bond enthalpy and bond order. Okay. First we will see the bond length. The equilibrium distance between the centers of nuclear of the two bonded atoms in a molecule is termed as bond length. See, this is one molecule, this is one molecule, here one nucleus will be there, here one nuclei will be present. Between these two divided by or two bond distance, okay, this is called bond length. Bond length is expressed in angstrom unit or picometer. Angstrom will be 10 to the power of minus 10, picometer is 10 to the power of minus 12. This is overall bond length. Next, factors influencing the bond length. Bond length increases with increase in the size. Okay, if the size is small, it will be bond length will be small. If the size is big, the bond distance will be big. That's how it get increases. Bond length decreases with increase in bond multiplicity, means number of bonds. If single bond will be length, double bond will be little bit short, triple bond more shortest. That's why. Bond length varies with the percentage of S character. Percentage of S character in hybrid orbitals. Bond length decreases with increase in the percentage of S character. Yes, how it will varies? By the decrease of increase in the S character, the bond length will decrease. See here, sp3 25%, sp2 33%, sp 50%. Okay, that is how the length will be decreased. Next is bond angle. The angle between the lines representing the orbitals containing bonding electrons is called as bond angle. Bond angle expressed in degrees, minutes or seconds. Bond angle determines the shape of the molecule. Presence of lone pair of electron distorts the regular geometry of the molecule. See, this is overall CH4. The two bonds will be, in between the two bonds some angle is there, no, that is bond angle. It will be degree or minus or seconds. If it is 1 dash minus 2 dash means that is seconds. The lone pair of electrons. Lone pair of electrons means, see, you can write NH3. Okay, 1, 2, 3. Remaining 2 will be like this. Lone pair of electrons will be written like this. The lone pair of electrons will pull towards the up. So, this distorts its shape. Naturally, bond angle determines the shape of the molecule. When the lone pair of electrons are present in the molecule, it will distort or it will disturb the shape of the molecule. Next is bond enthalpy or bond energy. The amount of energy required to break 1 mole of bonds of particular type of, so as to separate them into gaseous atoms, is called bond dissociation energy. From the amount of energy that bond should be getting break or that atom should get converted into gaseous atoms. So, it needs some energy, that energy will be called as bond dissociation energy. Bond enthalpy is a measure of the strength of a bond. Okay, bond enthalpy is nothing but a strength of a bond. Greater the enthalpy, stronger is the bond. It is expressed in kilojoule per mole. Factors favoring bond enthalpy. Bond enthalpy decreases with increase in the size of atom. When the size of atom getting more, obviously bond enthalpy will decrease. Bond enthalpy increases with increase in the bond order. Double bond means bond strength will be more. Triple bond means more strength will be there. Bond enthalpy decreases with increase in the number of lone pair of electrons in the molecule. When the lone pair of electrons will be present in the molecule, obviously the bond enthalpy will be decreases, because the lone pair will distort the shape of a molecule. Obviously the enthalpy of bond will be decreased. Next, bond order. The number of bonds present in the molecule or compound will be called as bond order. See here, the number of bonds present between the two atoms in a molecule is known as bond order. Increase the bond order, increases the strength of the bond and decreases the bond length. In single bond, bond length will be more. Double bond, little bit short. Triple bond, like this it will be there. Obviously strength will be more. In this isoelectronic species have same bond order. Okay, how means here F2, O2, 2 minus will be 18 electrons and the bond order of both species is 1. N2, CO, NO plus having 14 electrons each and the bond order is 3. Okay, this is how the bond order will be calculated. Next, formal charge on an atom in a molecule. Formal charge on an atom in a molecule is the difference between the number of valence electrons on the atom in a free state and the number of electrons assigned to that atom in a Lewis structure. Okay, assuming that in each shared pair of electrons, the atom has one electron of its own and the lone pair of it belongs to it completely. Means one molecule will be having bond pair of electrons also, lone pair of electrons also. What is bond pair of electrons? Which has been included in the bond formation. The lone pair of electrons which does not have included in the bond formation. But both the electrons will be belongs to the molecule or the central metal atom, that will be considered now in the formal charge. That is total number of valence electrons in the free atom minus total number of lone pair of electrons minus half into total number of shared electrons. Okay, that is the formula of formal charge. We will see some of the examples now. See, calculate the formal charge of BH4, that is boron hydride. How? See, boron will be having 3 valency 1, 2, 3. But minus charge is there, one more electron will be added. Okay, remaining 4 hydrogen. 1 valency of hydrogen, now bond will take place. Okay, this is BH4 minus. The number of valence electrons for boron is 3. The number of non-bonded electrons is 0. All the electrons are getting bonded, that's why 0. Number of bonds 1, 2, 3 and 4. Okay, now 3 minus 0 minus half into 8. 8 means 1, 2, 3, 4, 5, 6, 7, 8. Number of electrons getting shared. This is lone pair, this is valency. It will get minus 1. See here, write the formal charges on atom in carbonate. CO3 minus, this is carbon, overall oxygen, 2 minus. That's why again 2 electrons will be added here. Carbon atom V minus L minus half into S, 4 minus 0, half into 8 equal to 0. Formal charge on single bonded is oxygen, 6 minus half into 2. This is for carbon, this is for oxygen, single bonded oxygen, this is double bond oxygen. Overall 2, 4, 6. Okay. And here 4, 1, 2, 3, 4. And here 1, 2, 3, 4 will be present. Okay. See here, write the formal charges on nitrogen in each of these. NH4 plus, NH3, NH2 minus. In the NH4 plus, how? Okay. NH4 plus. Here one H. Okay. This is 1, 2. Overall 5 valency, 5 minus 0 overall bonded, half into 8 electrons plus 1. NH3 will be like this. The nitrogen valency is 5. 2 bond lone pairs will be there 2. Half into 1, 2, 3, 4, 5, 6. Bond pairs will be 3. Number of electrons will be 6, 0. NH2 minus is again will be minus means 1 pair will be there. 5 minus 4 minus half into 4. So it will get minus 1. Next, limitations of octet rule. Though most of the molecules follow octet rule, there are some exceptions to the octet rule which exhibit greater stability. Some of the molecules will not exhibit the octet rule, but also it is having more stability. What we will tell usually, which is following the octet rule, it will be more stable. But there are some limitations, there are some exceptions. By not following also it will be more stable. How? What are those elements? Hydrogen molecule. We know hydrogen is having only 1 electron. It will not follow octet rule, but it is also stable. Molecules with incomplete octet of central atoms such as LiCl, BeCl to BF3 boron hydride, that will also form. Molecules with expanded octet of central atom like PCl5, SF6, IF, etc. that will also with expanded octet configuration. Okay. It is also stable. Odd electron molecules such as NO, NO2, that is NO3, it will be having more stability because it is having electron, odd electron. Bonding in such molecules is explained on the basis of molecular orbital theory. Means it is having limitations, yes, but how it can be explained, that is also having some proof. It will be explained in the theory of molecular orbital theory. There you can see how the limitations have been overruled. So that will be seen in the next class. In the next session, resonance structures, polar character of a covalent bond and Fajon's rule will be discussed. So I hope you have understood whatever I have taught today. So thank you.